All right, so today we're looking at radicals. That symbol right there is called a radical. The square root sign, that is the official math term. It is a radical. Inside, we call it a radicand. Radicand. Okay. So when I'm looking at the square root of 16, we know that it's 4. Anything we're covering on this section, Monday or Tuesday, will not be on your chapter test. We've changed the chapter test to Thursday. So, let me just go through here. So if I square 0, we know we get 0. If I take the root of 0, we get what? 0. Same thing with 1. 1 squared, I get 1. The root of 1 is 1. 2 squared is 4. The root of 4 is 2. 3 squared is 9. You know, we can figure out our perfect square numbers. All of these in the first column, 0, 1, 4, 9, these are what we call perfect squares. All of these in the square root symbols under the radical are what we call rational numbers. Okay, they are rational because they give us a rational result, not an irrational result. All right, so our squares and roots in inverses. If we take 3, we square it, we get 9. If we root it, we get 3, right? Seems like they're inverses, right? But what happens if I do that with a negative number? Okay, negative, if I square it, I get 9. Then when I take the root of it, do I get negative 3? So they are not inverses, not exactly. So what we call that, because there is no square root of a negative that we can get a rational root or a real root. So what we do is we call this the principal root. Okay? The way we show negatives is outside of the radical. Okay? Something like this. We would show a negative root like this. So it's almost like a negative 1 times the square root of 16. Okay? That makes negative 4. Another way to look at it is this. In this situation, the first situation, what is the solution or possible solutions? Chris?
10.
10? Is that the only solution here? Yes. Negative 10. So in this case, when I'm squaring, I have 2 solutions. But when I root, I have how many solutions? 1. Because I can't, negative 10 times negative 10 does not make, I can't put a negative underneath. I can't, like negative 100. There's no number times itself that will give me negative 100. Okay? All right. So we're going to simplify each root below and identify it as a positive root or a negative root. So what is the root of this? Simplified. Let's go, Liam. 7. 7. Is it a positive root or a negative root? Good. Number 2, please. Sophie.
Negative 5.
And is it a positive root or a negative root?
Negative root.
Good. Okay, next one, Vivian.
It's 12.
And it is a?
Positive root.
Good. Next one, Alex.
4.
Good.
It's a positive root.
Good. Next one, 5, Jackson.
Negative 6.
And it is a?
Negative root.
Good. Okay, number 6, Sam.
6.
And it is a?
Positive root.
Okay, number 7, Miles. And it is a? Okay, and number 8, Jack.
No solution.
Right. We don't say no solution, we say no real root. Okay, do you remember when I had the big box up here with natural numbers, whole numbers, integers, rationals? Then we moved over to another circle and we called it irrationals. And inside the 2 were in a box. And then outside are these imaginaries, and that's the square root of a negative. So they're not part of the real number system, so is the reason why we say it's not a real root. Does that make sense, Harrison? Yeah.
Can that also be I?
We're not talking about that now. No, not at all. For your purposes, you are saying not a real root. Okay? Now, square roots need to be estimated using a calculator. We're not using a calculator at all. I don't want anybody using it. And if you practice it with a calculator, you will be screwed for the test. So don't use your calculator. Okay? All right. So I'm going to show you two ways. Oh, gosh, I said bad word, didn't I? Forgot I was recording. I'm going to show you two ways that we can simplify our radicals. Okay, so method number one is my way. If you have a good sense, number sense, my method tends to be work quickly, and you can do almost mental math and really estimate to the closest tenth. If you need to go to the hundredth, which most of the time for my course, I will have you estimate to the nearest tenth. And I will give you some wiggle room. So, the square root of 21 falls between what perfect squares? Anthony?
It'll be 16 and 25.
16 and 25, right? So I'm going to do this square root of 16, the square root of 17, the square root of 18, the square root of 19, the square root of 20, the square root of 21, the square root of 22, the square root of 23, the square root of 24, and then we've got, of course, the square root of 25. Okay? Are you with me? Yeah. We know what the root of 16 is. What is it? 4. We know what the root of 25 is. Now, there's two different ways they can ask this. They can say, what integers does the root fall between? And your answer would say between 4 and 5. But I want you to notice, between those two integers, there's a halfway mark. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 4 in and 4 up. And so I would say this would be my half. Would you agree that's the halfway mark?
Yeah.
There's 1, 2, 3, 4. 1, 2, 3, 4. That's our halfway mark. So if that's the halfway mark, what would that be estimated? 4.5. So what I use is an estimation system. And I use, what band does it fall between? 4 and 4.5 or 4.5 and 5?
4.5.
So can you estimate what the answer would be? 4.6. This is about 4.6, 4.55, 4.58, 4.59, somewhere in there. Now, what would I expect? Accept on a test. As long as you're within the correct band, I would take 4.6, 4.7. You know, you have a little bit of wiggle room. But I can usually get it within 1/10. Because you see, it's very close to 4.5. I know that's going to be like 4.55, 4.6. Does that make sense? Yes or no? Okay. So now, as I put it into my calculator, and when we're done learning how to estimate, I'll show you how to do it on there. And I put the square root function, and I put 21. I end up with 4.58. So we guesstimated 4.6. That's 2/100ths off. We took an educated guess. We didn't just guess. Okay, now, Miss Sophia does it a different way. And this is for people that need a pattern. A lot of people need patterns. And this is more exact to the hundredths. Especially the higher the number is in, like if you have the square root of 423. Right? 21, the square root of 21 falls between 16 and the square root of 25. Well, we know we have to always start with the lower number. What's the root of the lower number? It's 4. We know it's going to be 4 something. You with me? Except now, what she does is she finds a difference here. This is a difference for the numerator. So 21 minus 16. And here is the difference. This is the difference of the denominator. So 25 minus 16. So isn't that the same thing as 4 over 4? And the numerator becomes 5 over 9, right? And when we divide 9 into 5, well, we know that you should know what 5/9 is, decimal form. What is that? Anything over 9 is a repeated decimal. So it's the numerator repeated. It's 4.555555555, right? You forgetting that? Anything over a 9 is a repeated decimal. So they're giving us this. Really? They gave us the one in the calculator. We guessed 4.6. And the one in the calculator is 4.58. So the calculator is probably the most accurate. I mean, we're only, oops, sorry, not 4.8, 4.58. We are 2/100ths off. They are 3/100ths off. But the bigger the number gets, the more accurate her method is. Yes?
When it's a big number to divide, can we make it as a fraction, or do we always have to make it?
You have to go to a decimal, yes. So you can estimate or do this method. All right, so let's try. Yes?
So let's say you're doing a test and you got a big number, and we use your method, but it's pretty far off, but then her method is really close, but you're just using your method.
My method, you'll see, we'll get there. Like, let's try it again. Let's try the square root of 7. Let's do it both ways. The square root of 7, okay, falls between what prefix roots? 4 and, in fact, I'm going to put it in order. So 4, 5. I don't even think you need to do that. Let's just put it, it falls between the square root of 4, square root of 7, the square root of 9. This is how many digits away? 2 digits away. This is what? 3 digits away. Is it closer to the 9 or to the 4? So we know that it has to be what whole number? 2. Now, can you estimate? It's a little bit more than halfway, closer to 9. 2 point what? 2.6. 2 point. Yep. I would guess 2.6. Now, let's try so we guessed the square root of 7 is about, and as soon as you estimate, we use the about sign, 2.6. In Miss Sophia's method, she did 4, 7, 9. She says it's 2, and we put, the difference is 3, and the difference is 5. What do we get? What does that simplify to?
2.3 to 2.6.
It creates 2.6. It's the same thing. And when I put the square root of 7 in the calculator, so here's Sophia's, here's ours. In the calculator, they give me 2.645. So we're pretty darn close. Okay? All right, let's try a couple of others. Go. Okay, why don't you try 32? Go. Try 32. Pause the recording. All right, so the actual answer is 5.6. So the question is that somebody's asking is, so 32 falls between 25, not 16. I go to the closest roots, and this is 36. So this is closer to this one. So it's going to be more than a half. More than, what is this? This is 5. This is 6. It's more than 5.5, but not 6. Does that make sense? Okay, so we guessed 5.7 because the halfway point, this is 4 digits. This is 7 digits apart. It's way more than halfway apart. Okay? All right, you want to try one more? Let's do, let's do number 4. This should be super easy. Yeah. Shh, you should be able to do this in a second. Okay, pause it. Do number 4. Okay, Jack, what is number 4?
9.9.
Okay, how did you know that so fast without doing any work?
Because it's right next to 100 and it's under 10, so...
It's very close to 100, so your common sense should be kicking in. Okay, try the square root of 80. Let's do the square root of 85, number 5. Okay, pause it. Okay. All right. I want to hear from Anthony. What's the root of 81?
I got, 81 is 9.
9. And the root of 100?
Is 10.
So is it closer to the 9 or closer to the 10?
Closer to the 9.
Okay. So what's your best guess?
I got around 9.3.
Perfect. Did anybody else get something different? 9.2. But I told you within the same band, I'm okay with that. Because really, you're still within the same band. As long as you're too close, it's not that close to the halfway point. You've got to make better guesses than 9.4.
I got 9.9.
9.9, that means it would be for number 5? 9.9, you're almost at 100. 85 is not almost at 100, it's closer to 81. Does that make sense? All right, let's move on. I'm sorry I'm yelling at the iPad. I keep forgetting I'm... All right, so, what is this equal to? 11. Okay, raising a quiet hand. Number 2, Cheyenne. Come on. Negative 20, good. Okay. Next one, the square root of 71. Let me go with Edward.
8.9.
Okay, it's close to 8.9 for 71. 8.9 means it's very close to 9. 9 squared is 81. It's 10 digits off. Shh. Anthony?
It's like 8.6,
8.6, 8.7. It's from 64, it's 6 digits. From 81, it's 10 digits. So, what'd you say?
8.6, 8.7.
One more time. 8.6. I don't think it's 8.6. Okay, here's 64. Here's 81. It's 10 digits from here. It's 6, 7 digits here. So it's less than half, Anthony. Right? Does that make sense?
Yeah.
So it's 8.4, 8.3.
0.2.
Okay. I guessed 8.4. See, my guesses are pretty good, but I have a good number sense. So, what about this one right here? What does that really mean? Noah.
It can either be positive or negative 9.
Good. Number 5, please. Oh, so we're going to estimate it's between 16 and 25. Closer to 16? Perfect. Plus or minus 4.2. Good. Okay, 99. Square root of 99? Like 9. So 2 plus 9.9 and 2 minus 9.9. So your answer, you've got to simplify that. 2 plus 9.9 would be 11.9, and 2 minus 9.9 would be negative 7.9. Okay? All right. So if it is not a perfect square, so for instance, when we're here, if it's not a perfect square, it's considered irrational. 0, what's the root of 0? 0. So it's rational. Square root of 1. So it's rational. What about the square root of 2? No. It's irrational. It's like 1.41. Anything that's not a perfect square is considered. What about the square root? Is it rational or irrational? What about the square root of 4? Is it rational or irrational? Okay, square root of 5. Square root of 6. Irrational. Square root of 7. Irrational. Square root of 8. Irrational. Yes. You guys get the idea? Yeah. Shh. So, let me clarify. All non-perfect squares are irrational. Okay? Another way they can ask the question is, what two consecutive integers does the irrational root lie between? So it falls between 4, the square root of 4 and the square root of 9, so that would be 2 and 3. Do you understand? Alex, are you clear?
Oh, yeah.
Right, they just want to know what roots does it fall between. 20 falls between 4 and 5. You understand? All right, now, shh. More of the same. Shh. Guys, I'm recording, so please. All right, we could ask you a word problem. Finding the side of a square. Well, if we are looking for the root of 49, we know that that could be what? 7 or negative 7. But what do we know about negative 7? Yes?
It can't be a lake.
Measurement can't be negative. So all of your negative will be not part of the solution set. Because your solution cannot be measurement can't be negative. Okay? Now, if we get something like 40, we're just finding the square root, right? What is the principal root of 40? It falls between what?
36
6
and 49.
and 7. Is it closer to 36? Is it closer to 49?
36.
Okay, so what's your best guess? 6.4, I like it. I would have guessed that. 1/10 off. Very good. Okay, I suggest tonight you practice both methods. This, because you may be given, I want this estimated to the closest thousandth. Break up your methods. Okay? All right, that's the lesson.